Hello, today we are back here again for another video about differentiation and thesis. Yes, you heard me right. Now I know it's weird, but hear me out here. It's just some fun examples, sorta real life application examples, you know. So before we continue, don't forget to hit that subscribe button and join our Discord for homework help. Now, differentiation is the act of computing a derivative that helps us find the turning point and rate of change. For a simple graph like this, you can easily find the minimum point by drawing the graph. And in this example, the global minima or minimum is -2. But what if we have a complex graph like this? It's not quite easy to get the minimum or maximum. I mean, we can see from the graph the local maxima and the local minima. But the problem is we don't really know what the value is. And here is where differentiation is useful. By equating the derivative to 0, you can simply get your x values through a simple algebra. And once you have your x values, you can sub the individual x values into the generative function to get your y. But let's say I have two x values. Which one is the minimum or maximum then? Or in other words, how do I classify them? This is where the second derivatives comes into play. To make it simple, second derivatives are the differentiation of your first derivatives. Now if my second derivatives is more than 0, then I know that the x values and the corresponding y value is a minimum and vice versa. So that's a lot of theory. Now let's try. Given that the number of poop I make over a week is defined by a function, yt. So what is the minimum number of poop I will make this week? And before we start, let's recall the methods needed for differentiation. So say I have a function y. In order to differentiate, I will need to multiply the function by n. And my power needs to go for n minus 1. So back to the question. Now using the method I just mentioned, we can get dy dt, which is also the first derivative. Now equal it to 0, I will get the values of t, which is plus minus sub 5 over 5. Now that I have my t values, I'll just sub it into my original equation to get the corresponding y values. But I have two values where I'm not sure which is the maximum or minimum now. I have two coordinates, so I'll use my classification method, which is the second derivative. By substituting my positive t value, I found that my second derivative is positive. Therefore, it's the minimum. So to answer the question, the minimum number of poop I'm going to make this week is 1. Although not really healthy, but it's still logical. I mean, please have more poops, okay? Now before we try the next question, I'd like to share how I came up with the idea. So there's a research that studied the projectile trajectory of penguins' feces and rectal pressure. And they found that zookeepers should keep a distance of longer than 1.34 meters from penguins trying to eject feces by using differentiation. And yes, it's an actual scientific paper. So by modifying this, I came up with another question. So say that I have a penguin just hanging upside down on a tree, I don't know why. And I have a height equation that demonstrates the height at which the poop will reach given a distance, x. So now I want to find the maximum height that the poop will be projected at. From our previous calculation, we found these values. And now let's look at it from a graphical point of view. Say that my penguin is at the minimum location with coordinates sub 5 over 5 and 10 minus 2 sub 5 over 5. And I want to find the maximum height at which the penguin's poop will reach from the ground. So from our previous equation and calculation, we get that when we substitute the negative x value, it will be our maximum. And the corresponding height is 4.8 meters. So there you go. I know that the maximum height at which my penguin's poop will reach is 4.8 meters from the ground, and it will be 0.89 meters away from the penguin. So take home message, stay far, far, far away from a defecating animal, You never know when you will hit the jackpot. I mean, I've tried. Okay, in the more logical reality, the differentiation mentioned is often used in economics, say finding the maximum profit that your company makes, or even the maximum tax the government can implement in order to get the greatest tax revenue. In artificial intelligence, there are models based on differentiation used to train machines to predict an outcome, and a lot of other relevant fields. So it's not only poop maths, the application of differentiation is more relevant than you think, and it will be very useful if you choose to go into STEM-related subjects in the future. Okay, that's enough poop conversation for today. Remember to subscribe and join our Discord channel for more academic-related information. Thank you. Bye.